Hey again. So you might have seen that I already created a network visualization of the different hashtags that I use in my tweets using the tree. Now let's try to see how you can create something like that but with Vega-Lite. So before I forget, let me fork this and then let's rename this like Vega-Lite network visualization. So when you're doing that, like the first thing you have to take into account is that Vega-Lite per se doesn't have functions for creating the layout of a network visualization, but we can use D3 for computing the points and then use Vega-Lite for actually doing the drawing. So let's see if we can make another one on top of this as we have been doing for comparison. So I'm duplicating that. So now we have two networks in here. And then what I'm going to do is let's leave that like that. And then I'm just going to remove the part that does the D3 drawing. And this one as well. And finally, I need my tick function. So let's have that one in here. And then let's import Vega-Lite. Sorry for all the scrolling. Import Vega-Lite from Vega-Lite-API. So first we are going to do network, and let's call this chart like this. And I'm getting SVG node. Oh yes, so I don't have an SVG node, so yeah, no worries about that. So what we can do is that, and this is going to be tricky because one of the problems is that we need to be able to call a function that updates things. So let's start with this. So we could start by drawing things in here. And let's say that we want to draw a mark text. As you can see, instead of a node, I'm drawing the text directly. Then the data for this is going to be my nodes, and I just want to render this. Okay, so if I return that, that is my first part, and then ticked is not defined. There we go. So now we have the first visualization. So then after doing that, we can change the encoding and then say that for X, we are going to be using the field quantitative X. And this one is going to be without an axis. So something like this. Then we can do the same one for Y. And remember, like X and Y are two attributes that your force simulation it's going to be adding to your data. So, and these four simulations, you can establish what are the forces that you want in there. And in this case, I have a force for separating the nodes, another one for keeping them together, like in the middle. And then I have one for keeping the lengths, and I had added a boundary force that is the one that draws all of these nodes like around in the borders and don't let them escape the screen. So that way you can keep on seeing them. So by doing this, now I have these elements. It's not drawing any text because I didn't provide what was the attribute for that. So we can also have a bar text. And the field for this one is going to be the ID, and that one is nominal. So silly me, this should be false, false, and then it should be drawing the nodes. As you can see in there, is now drawing them. One of the problems though is that it's not moving. So what should we do such that it will actually move? So remember, if you go and watch the first part at least of the D3 version, like the one that is guaranteeing that it's actually going to move, it's going to be this tick function. But then the problem is that I need to make sure that this thing is drawing on that same Vega-Lite. So what I'm going to do is that I'm going to remove this from here. Let's return here the simulation. And then I am going to, let's call this simulation. And then in here, I'm going to say this is my chart. It's going to be this one. And I need to have a function that actually does like an update, okay? So for that, what I'm going to do is that I'm going to create a target in here. And let's see if I can remember how to do this. And this target is just going to be a div, okay? And I want to be able to draw this visualization in there. So By the way, this, oh yes, so let's say this is going to be an update function, and this is going to be nodes and links, okay? And now I have my nodes and my links. Yes, so it should be, instead of chart, it should be update, and then it receives the nodes and the links. That's good. So the thing is that this one, I wanted to draw on the target. So one way of doing that, and it's not very well documented, but this returns a promise. And then out of that promise, you can call then that is going to give us, that is going to be resolved when the promise is resolved, or is going to get called when the promise is resolved. And then it's going to return what it's called a Vega view. And the Vega view, it's going to be what you are going to be adding to your chart. So in this case, what we can do is that we can say, this is what I want to draw in there. So this is going to be updating my thing, and then it's going to be appending that element into that. So the other thing I can do is that since I want that to be updating, then what I'm going to do, and probably people from VegaLite will say that there's another option where you can just update the data. That's something that I have to check. But in here, what I'm going to do is something way uglier. And then what I'm going to say is like, just remove the previous children and then just append this child. That is going to be this one. So with that, I can check if this works, and let's see if it does. I forgot to check first. Okay, good, it's drawing now. And then the other thing I'm going to do is that my tick function, that is this one in here, what it is going to do is just be calling update with my nodes and my links. Okay, so of course I have an error because I already have a semicolon in here. And then now it's moving, so it's actually working pretty well. And one of the things I like about doing these things with Vega-Lite is that, like, remember the force boundary? That's a force that you need to add in D3 such things don't go away. So actually, let me show you what happens when I remove the force boundary here in the D3 version. As you see, like, nodes just fade away. So if I actually do the same thing on Vega-Lite, it adjusts the scales to be able to draw each one of those. As you can see in here, it's actually zooming in and zooming out, so we can see those elements. So having done that, we can change some other stuff. Like, for instance, let's say that I want to change the color to be the field numerical, and that's going to be the cluster. Let's say that we also change the size, and we can do that right away. And this is going to be how many times the word appears, or the hashtag appears. So that's going to be my value. And then now you can see like really big ones, as you see in there. We can say that the scale for this is going to have a range that goes from, let's do something not that small, to 20 maybe. So that way at least you can see the other ones, maybe a little bit smaller, so the other ones fade away a little bit more. That's better. And then what else we can do? Okay, good. So I have been only drawing the nodes. So let's say that I want to draw the nodes in here. And instead of putting this like this, what I'm going to create is that I'm going to return a layer chart that shows the nodes. So by doing that, I create here my nodes. Oh, I have already had that. So let's say these are the texts. And then let's put them here as texts. And then with that, I have that part. And if I want to draw the links, then I can do the same thing in here. And then in there, I'm going to call them lines. This is going to be a mark line, I think. And then like the important thing is that the data for this is going to be the links. When you check the links, basically each one of those is going to have the source and the target. So what I can do is that this can be a line that is going to go from my source .x to my and my source .y. to my, and this is the second point of the line, and it's going to be a field. I don't need to say that it's quantitative because it's going to assume whatever type of data that you pass on the first one. And then for Y2, I'm going to change this one, and the text, this doesn't have a text. Cluster, if you want to color code by that, let's not do that. But what we want is the opacity. So let's see what we do if we pass it like this. So I want to see that the links have different opacity depending on the value. Then of course it doesn't show anything. Oh yes, like one of the things is that I have to include it in the layer. And then doing that, now we have this element. So it created a whole line on the whole thing. So there is another one that we can use for that, the mark rule. And that looks a little bit better. Let's say that you want to change the opacity. So of course I made a mistake in there. Here. And that helped a little bit. And then let's remove this a little bit in here. And then if you want to show that behind the elements, so it can be something like this. And the other thing is that that's too strong, so I can change the range of my opacity. So I can say that the scale is going to be on a range from 0 to, let's say, 0.7 or something like that. That helps a little bit, but maybe it's too stringent. So let's say 0.9, but add a color. And let's say this one is what, CCC maybe, so it's a gray color. That's a little bit more doable. I don't get the dragging in here, but one of the things that could be really easy to do is having zoom and panning, which you can add very easily on Vega-Lite, but I don't remember on the top of my head, so I'm not going to add it in here. So let's see what happens if I do this. Yes, so with the grayscale, it works a little bit better. So here you go. So you have this visualization. Here is the other version for this one. And as you can see, it's scaling and moving on the screen. If you want to add the force boundary that I had in here, that way nodes won't span that much. So at least they will still, and it will look a little bit similar to what we have on the other one. Now, really quickly, let's see if we can do a matrix visualization of that. And the way of doing that will be a mark rectangle, I think. Let's say that I want to reuse this one. And so I think I can do it with only one, so I don't need layer in here. So I'm going to say this is going to be my mark rectangle. The data is going to be my nodes, which I don't have here. So for this one, I'm going to do the following. I need to have the X and Y's. So I had this part where I was making a copy of my nodes and my links such that I won't get any collisions in between the elements. Or actually, you know what? Let's do another trick. So what I'm going to do is that I'm returning the simulation in here, right? So I can say, or actually I think I can just do that. So I can just say simulation.nodes, and this should return my nodes. Good. So I have that. Then I need my width and my height and render. So I'm going to put that in here. So now it starts rendering. So I have rectangles. Okay, so basically what I want is not the nodes, I want the links, and then I want for the X position to be source X and the Y position to be the source Y. And I want to show this is in okay, so yeah, sorry. So basically what I want is not the X and the Y, what I want is the ID. and it's going to be from the source. That makes more sense. So I want to make a matrix that goes from source to target. This should be a square, so we are going to do it like this. And of course, this is not giving me the links, because for getting the links, you actually get it from the links force. And there we go. And then I have this one, so this should be a field ordered order. I don't have any text. The color, and this is the link, so this should be value. And size, I'm not going to pass. And then now you got it. So basically, it's a matrix representation of that. If like the rectangle might be too small because it's like too many of those. So sometimes I just cheat doing something like this. And then something else that it's important to keep in mind is that we are only seeing like half of the matrix in there. Now the other thing we want is to sort by the cluster, because that way the matrix representation is more readable. So I think we can do in here sort, and then we say that we want to sort by the source dot cluster, maybe something like this, and then that's much better. I am a little concerned that it's actually drawing the whole thing. What can be wrong in there? Let's say if I do this, it's going to be too many. Yes. So let's leave it on false. Let me see. This one should have that element. I'm missing something in here. These are the links. Here is the color. Oh, interesting. So, oh, good. So basically, here is my first, yes. So the color, I actually want it to be the cluster. So let's say this is going to be my cluster. That makes more sense. And then, good. So I have a ton of clusters in there. And then at least it's trying to put them on the top. So I guess let me wrap up in here. As you can see, like you still get a little bit of the diagonal. It's a very sparse matrix network. So because of that, it might be working better as an outlink representation, as you see in here. Something that could be interesting, for instance, is let's say that you only take like only the last tweets. So that gives you less elements in here. So in the matrix, it starts becoming a little bit easier to understand. And again, remember that you can add elements in here like the tooltip. So that way you can just move in here and say, these are all the database tweets and where are they going to. So as you can see, you can play with all the sortings. I might be making a mistake in here. Like for instance, let me try this quickly just to see if the organization changes a little bit. Seems like not so much. Oh yeah, like it actually, I guess in here will make, but at least like you can see this seems to be a little bit more clustered. So that's something in there. So anyhow, that is how you can create network visualizations using Vega-Lite. Sometimes I actually prefer doing it with Vega-Lite than with D3, even though you can do this dragging and all of that, just because it's faster and the whole ability of scaling up and fitting what all the network visualization on it. It sometimes is very useful. So hopefully you can use this for your network visualizations.